Begin. So we are taking 3.5, what we learned last class, but we're going to apply it to word problems. Like all things in math is pointless if we don't apply it to something, right? I always talk about that. Applications of math, that's what science is, really. It's applying math. So we're going to take the concepts of 3.5 and we're going to apply them right now to word problems. This is our last section before our test. This is our last section before our test.
When is our test?
Okay, our test is on Friday. Okay? And it seems like we have a lot of time before Friday, but we don't meet every day before Friday. Okay, so keep that in mind going forward. Do we meet tomorrow or we don't meet tomorrow? Wednesday we're going to review. Thursday is a C day, if you saw your schedule, which is because we have math, 32-minute periods. So I'm going to review on Wednesday. On Thursday, you're going to present your projects for 32 minutes. We might not get through everybody, but everyone's is due on Thursday. Everybody is due. If you don't submit it, it's late on Thursday. Okay, everyone's project is due Thursday. We either present Thursday, the people who didn't present Thursday will present on Monday, which is fine. Grades are not due until Tuesday. So your test is on Friday, so 3.1 to 3.6. Keep that in mind. So we're going to apply these word problems. Let's take a look at this first example. Oh, look at this. These are random names from like 5 years ago, and both of you are in the class. See what
Jimmy and share your fortune.
Jimmy and Sam, yeah, yeah, Jimmy got a couple more dollars to Sam. We're working hard lately. I don't know. These are random names that have never come up, I think, honestly. I don't think I've ever had a Jimmy. I've had James, and I don't think I've ever had a Sam in class ever. So these are two unique ones here. So Jimmy, or Jim in this case, has $17 more than Sam. They have $73 together. How much money does each of them have? Now, this is the beginning, so it's a little bit easy, and a lot of you are like, wait, we've done this already, and we have kind of done this already.
Can't we solve this with just a one variable?
Yes, and very good, Sean. That was, you're reading my mind. It's like you have telepathy, Sean. I was thinking exactly that. You could solve this from Chapter 2 material and Chapter 1 material with one variable system. You could definitely do it. But because today we're starting two variable system word problems, let's define them as two separate variables just to show. So let's let J equal the number of dollars that Jimmy has. And let's let S equal the amount that Sam has. Now, because of the fact that we have two different variables, we need how many equations? Two. The first equation, that's pretty simple. Jim has 17 more than Sam. Give me an equation for that, based on my variables given. Gus.
J plus 17. J minus 17 equals S.
J?
Minus 17.
Yeah. And I would have personally written it as J equals S plus 17. But it's the same thing, right? When I read the problem, Gus, I'm reading it as Jimmy has, so J equals 17 more than 17 plus Sam. But again, if I move this over, I get that, right? So either way is acceptable here, but I want you all to recognize that. If you wrote J equals S plus 17, that is totally fine. What's the second? So that comes from this. Let me use some color coding here. What's the second equation from the second sentence going to give us, Clark?
J plus S equals 17.
Yeah. And that's the second equation right there. It's a system. When we have a system, we should use substitution, or elimination. Substitution or elimination. Now, because of the way it's set up, I would use substitution, personally, because S is already solved for. So because S is already solved for, I would take this expression, which is represented here, it is equivalent to S, and I would substitute it in for S in the second equation. But again, if you just now wrote down J equals S plus 17, then take S plus 17 and substitute it in for J. You'll get the same answer, right? You'll get the answer for one person, while the other person will get the answer for the other. Either way, we're finding out how much each of them has. When I substitute that into the blue equation becomes this. So I've taken equation 1 and substituted it into equation 2 to yield a brand new equation, which we can call, if we want, equation 3. And then solve. Subtract 17 and divide by 2 all in one step. What do we get? Subtract 17 and divide by 2 all in one step. Careful. 28. Check your work real quick. If you added 7, I'm sorry, I subtract. I'm wrong. I apologize. Add 17, I said it wrong. Add 17, 45. You answered the question I asked. I like that, Nick. Thank you. No, because I said it wrong. I said subtract 17. I mean, I clearly meant add 17. And I think Gus said 45, which was right. It was 45. That is correct. Yeah, but thank you for asking the question I asked. That's correct. So add 17 to give you 90, and then divide by 2 to give you 45 for the amount of money Jimmy has. Well, if that's the amount of money that Jimmy has, plug it back in. Sam has 28.
That's my lucky number.
Is that your lucky number, really?
It is. 28 is my lucky number.
This is just random. I've taught this lesson, Sam, for like 10 years now. Since I was at my old school, I had some of these numbers. It's your lucky day. It means you're going to do well on the test on Friday. That's what it means right there. We get where this came from, right? We get where this came from. Plug the value of J back in to the expression right here. 45 minus 17 gives you 28. So a rather easy problem to start with, right? One that you've probably all seen before in Algebra 1, and we kind of saw this in Chapter 1 itself already. But we did it with one variable instead. Andrew, do you have a question or are you just stretching?
No.
Okay. Jump into the second question then. This one could be a little bit tough because of the wording. It's out of an older text, and I use the phrase jet stream a lot. Let's talk about what that means. So a passenger jet took 3 hours to fly 1,800 miles in the direction of the jet stream. What does that mean? Who knows their science? What does the jet stream actually mean? In the direction of the jet stream. What do you think, Graham?
I think it's either like the way the turbines are going, like when the jets are moving, or like flowing where the air is.
You're on the right track, yeah? On the right track, no matter.
The jet stream is where the air is blowing.
So it's just the wind, the second part you have, not the beginning turbine. So the jet stream is the wind, pretty much. So in the first case, it says in the direction of the jet stream. And then it says the return trip is against the jet stream. So it's with the wind on the way, helping you. The wind is physically helping you. And on the way back, the wind is acting against you. The jet stream, the wind. If you want to write wind instead of jet stream, that's fine. Okay, because I recognize that the word jet stream is not commonly used as much as it used to be. Okay, in the direction of the wind and then against the wind. And that's logical, right? If you're traveling against the wind, it should take you longer. That's logical for numbers. And the question says, what was the jet's speed in still air? And what is the wind speed of the jet stream? Or what is the wind speed? What is the wind speed is what we're looking at. Forget the word of the jet stream if that confuses you, okay? Don't worry about that. So what are the two variables we're looking for here? Because those become my unknowns. My let statements are a function of what I'm looking for in the problem. This problem is not asking me to find distance. It's not asking me to find time. It's something else it's asking me to find.
It's asking for the jet speed without any wind and the speed of the wind.
So the jet's speed, or the plane's speed, we'll call that x. And let's say the wind speed is y. Now, here's a little bit of science. Remember how I say applications of math and word problems are really just what science actually is. Think about it logically. If I'm going in this direction, all right? How many people are on the cross-country team right now? Nice. We got one. All right. Neighbor, you're our test subject, right? You're in Central Park. You're doing your 5K, which is about half a loop, right? 3.1 miles, about half a loop. You notice that when you're running in this direction, the wind is against you when you're running north, right? So what is that going to do to your speed? Is it going to help you or hurt you? It's going to hurt you for sure. And then what happens though after you make that turn at the north left and you come back?
When you go back,
Assuming the wind doesn't change.
It starts helping you.
Yeah, it starts to help you. So again, it hurts you on the way there when it's against you, but it helps you when the wind is with you. Hurts you, I think of subtraction. It subtracts from your velocity, doesn't it? When it helps you, what does it do to your velocity? It adds to your velocity. What's our formula for distance rate? What's our formula? D equals RT. Well, in the first case, what's the distance traveled on the way there? 1,800 miles. In the second problem, when you come back, what's the distance traveled? And if your parents are pilots, I know this is not always true. Right? It's not always. But what is the distance on the way back if we assume it's a round trip? Also 1,800. So we've got on the way there, we'll say with the wind, and we'll do the second one against the wind. Now, that's the distance. The time is given. On the way there, it took 3 hours because you were with the wind. On the way back, it took 4 hours. So the question becomes, what goes in the parentheses for the rate at which the plane is actually traveling? If I'm running, as we just did the example in Central Park, and let's say I can run with a velocity of 7 miles per hour, and the wind is pushing me with 3 miles per hour, what do I feel like I'm running? I'm going with 7, the wind is helping me with 3, I feel like I'm running? Because I just did what to those numbers? Yeah. So what do I do here? X plus y. It's the speed of the plane, which is x, the speed of the wind, which is y. Y is helping. The wind is helping on the way there. Sean, what are you going to tell me for the next part?
So, if you're going against it, you have to subtract from the speed.
Therefore?
X minus y.
Very good. Take a look at this problem. I want you to understand the physical, conceptual nature of it first. The math we'll do in a minute. The math is simple, actually. It's real simple. Hint, don't distribute. Don't distribute. Remember I talked about how there's times when distribution is not actually important? How, yeah, it's very tempting to always distribute. It is very tempting. But if you don't distribute, instead it makes the problem a lot quicker mathematically. Conceptually, though, do we get this concept? The distance traveled is the same because it's a round trip. The time on the way there is less because the wind is helping you. Helping means add the wind to your speed. Hurting you means take away the wind speed away from the plane speed, and it's going to take you longer. Why did I say not to distribute?
Because it's going to take a lot longer because you need 3x plus 3y, and then you have to divide by.
And then I have 4x minus 4y, and then I'd have to get... So what should I do instead?
Just divide by 3 in the beginning.
So divide this whole equation by 3 on both sides, and the second one by 4. It makes life so much easier. Sometimes this is just intuition. It's not always going to be something you're going to know how to do right away. 1,800 over 3 is 600. 1,800 over 4 is 450. Now look at how nice this is. What method should we use to solve this one? What method is it set up for perfectly? What method is ready to go based on this arrangement, this setup? I'll tell you, what do you think? Elimination, why?
Because x and because y and y on each one has a different sign.
Yes! We want opposite coefficients for elimination to work. Remember, we want opposite coefficients for elimination to work. And indeed we have them. Y is positive, y is negative, both with a unity coefficient. We can add straight down at this point. Adding straight down. This whole thing becomes 1050 equals 2x. Add straight down. It becomes 1050 equals 2x. So x is 5 1/4. 525. So I would plug it back into, ready? Take a look where I'm pointing. I'd plug it back in here, actually. I would not go back to my originals. Is everybody clear what I'm saying? You can go back to here, it's fine, you could, but then you got to do more math and divide still. So provided you did your math right, I'd plug it back in right here. If x is 525, what's missing for y? 75. 525 and 75 is 600. 525 minus 75 is 450. So y is definitely 75. And these numbers are reasonable. An airliner travels at speeds of around 500 miles per hour. The wind, believe it or not, at that altitude is actually speeds of around 75 miles an hour. It's kind of crazy to think about that. And when you drive and you think it's a windy day, you might hit wind speeds on a windy day of like 30, 40 mile an hour gusts, 50 if it's like a storm you're traveling through. And the higher altitude you get, crazier it is up there. Okay, that's why you have turbulence. That's a whole other system. Okay, but again, the plane, the wind. Add them together, you get 600. Subtract the 2, you get 450. It does check out. Okay, the math does work. Questions on number 2? Questions at all on number 2? Okay, let's go to number 3. Spend about a minute listing your givens and trying to come up with your equations. You don't have to solve. List your givens and come up with your equations. You should have this done at this point already at least. Just based on what it's asking. You don't even have to know the equation. That should be true. Well, you have written down. You can use whatever variables you like. But because you're answering the question of how many of each, how many, that's what we're actually looking for our let statements. Remember, the let statements answer the question at hand, always. The let statements always answer the question at hand. How many 2-pointers? How many 5-pointers? Now, some students intuitively get these really well. Others struggle a little bit on these kind of problems. If it's not coming to you, it's not clicking, it might be worthwhile to think about units. I talked about units already in this class, but it might be worthwhile to think about the units. So when you're putting these formulas, equations together right now, think about the units involved. Can somebody give me one equation that would be useful? Andrew, go ahead.
2x plus 5y equals 145.
And this is the one that's actually a little bit tougher to get. 2 points per question times the number of questions. Plus 5 points per question times the number of questions equals 145 points. My units balance. I have a number of points plus a number of points equals a total number of points. And I can check that before I get to the second equation. I can check that with my dimensions if I write them. 2, right? It's 2, the units are points per problem. So this is in points per problem times the number of problems plus, or questions. I said problem, I should say question, same thing. This is really number of questions, not problem. And then this is again points per question times the number of questions. And this unit is points. So just make sense of it. Number of questions cancel. This gives me a certain amount in points. Number of questions cancel. I get points plus points equals points. My units always have to match up for these problems to make sense. They have to. Okay, and again, 2 points per question, x questions, plus 5 points per question times y questions equals 145 points. That's the first equation of 2. What is the second equation, which is really the easier of the two? Bridge. X plus y equals 50. And I can do units on this one, but there is no unit analysis. X is the number of questions asked. Y is the number of questions asked. How many questions were asked total? 50 questions were asked total. So the second equation is just number of questions plus number of questions equals the total number of questions. So those units have to match up there. So I'm going to take these two equations and combine them. How should I do so? What do you recommend here? Because either option is fine, honestly.
Elimination, I guess. So multiply x plus y divided by -2.
Yeah, let's multiply this entire second equation by -2. But if you chose substitution, it's probably just as easy in this problem because x and y can easily be solved for, right? Look how easy it is to solve for x and y. So if you choose substitution, that's fine. Okay, remember on the test, if I say solve by elimination, I just want to see that you have the skill, that's all. So please heed the directions and solve by elimination. It says so. Word problems, I'm not going to tell you which way to solve, so it's up to you to pick whichever one's easiest. This equation becomes negative 2x minus 2y equals negative 100. Now I'm going to take this equation from up here, in case we're forgetting where the second equation comes from. I'm going to re-jot it down real quick, just so we've got them next to each other so we can see the elimination happening. And when I add straight down, I'm adding those things straight down. So again, I took the original equation, put it back down here, multiply negative 2 by that equation. X's drop off. We get 3y equals 45. Therefore, y equals 15. If y is 15, and there are a total of 50 questions, x must be 35. This is one of those times where it's really important that you make a verbal statement in your answer. A verbal statement in your answer. So, on a test, you should finalize this question with the following. I need my let statements. Let me grab my let statements. I look at my let statements, and I see, okay, x was the number of 2-point questions, right? So I would start by saying, there are 35 2-point questions and 15 5-point questions. Literally making a verbal statement as to what my answers mean. Yes, I know that these variables make sense, and you defined them earlier, so I could probably go back and look and see what it was, but you need to understand what it is, and I need to know that you understand what it is on the test. So a verbal statement at the end of these problems is pretty essential. Just like the last problem, you might want to have said that the plane itself was traveling at 525 miles an hour while the wind speed was 75 miles per hour. That would be a good verbal statement to make at the end of these problems. Yes? Okay, so word problems with systems, verbal statements at the end are very important because we have multiple variables. We need to know which is which. We don't want to confuse the two. Questions on number 3 at all? Questions on number 3? All right, good. Let's go right to number 4. Number 4 is a little bit trickier, and number 5 is the trickiest of all. Together, John, Bobby, and Kristen have $70 right away. What are you going to write, pretty much? Just tell me off the top. I'll tell you. Go ahead.
Read that statement. That x equals x minus a.
Perfect.
X equals the amount of money John has.
Go ahead.
Y equals the amount of money Bobby has. And Z equals the amount of money Kristen has.
Exactly. So right away, we know which 3 we're going to look for. Okay, we know which 3 we're going to look for. And the problem at the end says how much money does each of them have, so I know we're looking for each dollar amount. And I know we're going to use all 3 based on the first sentence alone. So the first sentence alone, give me an equation that I use for the first sentence alone, John.
X plus y plus c equals 70.
So already, we'll notice it's a 3-variable system, We're going to show today how this is pretty easy to solve. Number 5, we're going to solve with the matrix. So I sure hope you did your homework this weekend and watched that video. We'll practice it today with the matrix for number 5 in a minute. For this one, we'll do it by hand, actually. It works by hand, pretty easy. The second sentence says, together, John and Bobby have $39. Right? Together, John and Bobby have $39. What do you got for me?
I did b plus j equals 39.
Well, in this case,
Sorry.
that's all right. John and Bobby would be?
Y plus x.
Correct. And I'm going to keep it in the same order like this. See what I'm doing?
Yeah.
Based on your matrix video, you recognize how important it is, right? That thing's lined up. So you'll know why I'm talking or why I'm doing it like this if you watched your video. And then last but not least, it says, while Kristen has $4 more than Bobby. Kristen has 4 more than Bobby. What do you got, Jimmy?
Oh wait, sorry, I'm reading the J.
That's fine. Okay.
So Z.
That's fine.
Back to me. I got myself confused.
I'll come back to you. Yeah, I'll come back to you. Clark, help me out.
Z equals 4 plus y.
Z equals 4 plus y. That says Z is Kristen, good. Equals, good. 4 more than, good. Bobby, which is y. Perfect. Now, I might not want to leave my equation like this so it's not the same. So I might want to manipulate this a little bit, but that is the correct equation to use. Well, how should I write it? Or is that what you're going to mention?
What?
Were you going to mention how I should write it? No?
No.
Okay.
You should write it as
Y
y plus 4 equals z.
plus 4 equals z. I wouldn't write it that way, no. We can do it that way. We definitely can. We can do substitution, which we're going to. But if I were solving in a matrix, Sean, remember that was the question. If I were using a matrix, how should I write it really?
Y minus z. I mean, y plus, negative y plus z equals 4.
Yeah. Move the y over by adding a negative y to both sides. So if you move this y over, you'd really just be subtracting y on both sides, right? So let's add negative y to both sides. And we could rewrite this last one as negative y plus z is equal to 4. And I can kind of cross this guy off now. Okay, it came from this though. I'll write it at the top so we have it over here. That became that guy right down there. Now, I would write it that way if I were solving with a matrix. And this can absolutely be solved with a matrix. What would go in the place of something that's missing? It's not there. What number represents nothing of it? 0. So there's really a 0z and a 0x over here. Let's make sure that that's known. So if you want to practice with matrix, you can. But, if you want to instead, watch this. You could take this expression right here, substitute it into equation 1. And then using equations 1 and 2, you would only have x and y. And you could solve a system that's 2 by 2. Again, you could substitute the expression 4 plus y right here, and then this would be x and y, and you could just solve these 2 equations as a result. Another way?
So, once you find out the second equation, you can immediately figure out z because you just plug in 39 for x plus y, and you get, what is it? It's 31.
31. Well done. So take a look at what Nick noticed. X and y together is 39. Everybody see this? Take a look. X and y is 39. So it makes this right here 39. 39 plus z is 7. So Nick said, hey, if you know that x and y together are 39, then x, y, and z means that this has got to be 31. 31 and the 39 that this is gives you 70. Absolutely. Good job. You can do other stuff. You got another one?
Yeah, and then you can just subtract 4 from...
To get the y value. Yeah, once you get that z is 31, you can put the 31 in there to get the y value. Once you know y, you can plug that back in here to get the x value. There are like 3 or 4 different ways you could actually approach this problem with substitution method. It's totally up to you to decide. As long as you show your steps, please. Show your steps if you're going to solve the substitution. Okay? In the end, yes, we get z is equal, and again, you could solve it any way you'd like. And I would approach it with the way that Nick actually said. I think it's the fastest way. It makes the most sense. So let's take away this idea of substituting the entire expression. And let's do what Nick said and recognize that if x plus y is 39, let's replace this with 39 right here, which yields z equals 31. If z is 31, then that means that y must be 27. Right? If z is 31, and I plug a 31 in for z up here, then y has got to be 27. If y is 27, then x has to be 12 to add up to 39. So I would progress my way through that in that direction. Okay? And again, it depends on which way you choose. This alone right here, this statement alone is what gives me the z value right there. And how did I get that? I got that by plugging 39 in for the sum of x plus y. Okay, 39 goes in for x plus y, giving us z. Once you know z, you know y. Once you know y, you know x. Doesn't matter which way you want to choose to solve it. Okay? Let's do the last one together so we can get to the matrix part. Okay, let's go to the last one. Take a couple minutes and just take some time to write the equations first. Okay, write the equations first. If you get all the equations written and you want to jump into the matrix, you can. Jump into the matrix. Any Matrix movie fans in the room or not? Has anyone seen the Matrix? Yeah? It's an incredible movie. The whole trilogy is great. And jumping into the matrix is kind of actually. What if we live in the matrix? You ever think about that? After watching that movie?
That'd be scary.
Does it blow your mind to think about that? Like right now, we might not even really be beings.
Well, like the underground part. That freaked me out.
Or what?
Like the underground part.
Oh yeah, the underground world that exists outside of the Matrix.
It
Yeah.
doesn't really make any sense though.
Humans are
less energy
batteries.
than
It doesn't make
batteries.
sense about
It doesn't make. You could use good potato to make more energy.
Well, humans that are fed nutrients do produce energy. They're not.
It varies.
I know, but the concept is that they're harvesting enough humans to use all the energy from humans. It's a crazy movie. If you haven't seen the Matrix, the trilogy, I'd recommend it. It's actually really good. I have it. By the way, these are my brothers, Michael, James, and Joe. My three brothers. So I use them as examples. And I used to go to, not Shake Shack. Anybody go to Checkers? Checkers ring a bell? See, no one knows of Checkers.
Oh, I know
Oh,
it.
you know of it?
Yeah.
So that's a fast food burger joint, yeah. When I grew up as a kid, Checkers was right around the block.
It's a mix between Juniors and like Burger King.
Sure, with better fries and milkshakes. They have banana milkshakes, strawberry milkshakes, and seasoned fries. Checkers is one of my favorites. Anyway, I changed to Shake Shack because I feel like no students knew what Checkers was. So how would I represent with an equation? How would I represent with an equation what's underlined in red? And use the first letter or use X, Y, Z, it doesn't matter. The goal is to figure out what each item costs, right? So we know that those are going to be our three unknowns. How would I write the first one? Go ahead.
5x
5 burgers.
plus free, free y
So 3 orders of fries
and free free z
and 3 shakes
equals 35.
are $35. Okay? So again, what would X be? What would Y be? What would Z be? X would be the cost of a burger.
No, just math burgers. 5's the cost.
Careful. Try again. Look at it again.
Yeah, 5. X is the cost.
Oh, yeah.
You see how Y was the amount? 5 was the amount, yeah.
Yeah.
So Y is the cost of
Fries.
fries.
And then Z would be cost of the shake.
That's a good point you made there, though, Sean. That sometimes problems will give you the cost per item and ask you to find out the number of items. Some problems give you the number of items and ask you to find the cost per item. But in the end, what are you still doing? Multiplying. So it's kind of the same approach to the solution to it. Okay? It's kind of the same approach. How about in blue? A week later on their second visit, what equation can I write from that? Gus?
4x plus 5y plus 4z equals 39.
So 4 burgers, 5 fries, and 4 shakes is $39. And finally, on the last day, they go burger happy. 6 burgers, 4 fries, and 3 shakes. So I would not solve this by hand. Let's all take out our calculator, please. I'll do it on the board with the calculator for us. If you were a bad student this weekend and didn't do your homework, this might be a little bit confusing. So just try to catch up. That's all I'll say for now. I'm going to put up the calculator so you can see it.
How come the battery life lasts so long on all of these instruments?
You have, show me. Show me. Yeah, because, I mean, it's very little consumption. I mean, it takes almost no energy to run these things, literally. And when they're not on, they don't use any battery at all. So imagine your cell phone. So you guys don't even know about, this is crazy. So before cell phones had everything else involved in them, when they used to be actually just cell phones, the battery would last like 3.5 weeks, literally. 3.5 weeks, 4 weeks. Like my Kindle, I have a Kindle that's only the black and white one. I don't charge it right bi-monthly.
Yeah.
Literally. Every other month I charge it. Is that bi-monthly? Semi-monthly, whatever the word is? Every other month. I don't charge it ever because it's a black and white. It doesn't really take a lot of energy. Phones now, because they do so much more, take a lot of, even iPods. Before iPhones were existing, there were iPods, and then there were cell phones. An iPod that just played music would last like a month and a half before it died, because all it did was play music. So it's because your phone is doing so many things, constantly looking for Wi-Fi, constantly updating its location, constantly like syncing your email, syncing your calendar, getting all those messages you guys chat with all the time, all the notifications. Every time you get a notification, there's a drain of your energy right there. Anyhow, yeah, calculator is doing much less than a phone is. So you're comparing the two. It's not really comparable. All right, so let's do this together. Let's press second, and then we press this button that says matrix. It's x to the negative 1, but it's the second command. So second, and then press x to the negative 1 to bring up the matrix. Now, this is what you're seeing. If you practiced over the weekend, you might have stuff that says 2 by 3, 3 by 4. It's fine if it does, don't worry. Go over to edit. Go over to edit. Press the right arrow key twice. Let's edit matrix A. Now, before we start anything, it's always rows by columns. Rows by columns. We have 3 rows in this problem. Let's go back to the iPad so you can see it. We have 3 rows here. And we have how many columns? 4 columns. The constants count as a column. So let's type in 3. Let's move over and press 4. And let's enter the matrix. For the movie people, you're going to be like, this so cool. Your matrix might not show all the parts. You might see only the first 3 columns right now, and then see a dash. It just goes off the screen, so you're going to have to press to the right. If you only see 3 columns right now and then a dash at the end, you have to progress off the screen. Take all of your coefficients and just simply type them in. 5, 3, 3, 35. 5, enter. 3, enter. 3, enter. 35, enter. Literally type in your coefficients when you do the coefficient matrix. You'll learn more about this technique in what's called linear algebra in college. Type in the next row. 4 burgers, 5 fries, 4 shakes for $39. Type in the third row. 6 burgers, 4 fries, 3 shakes for $42. I'm getting hungry. Whew. Now, we've got the matrix input. We don't want to do anything else inside of the matrix, so we have to quit out of this completely. You can't just go and type something in next. Go back to the home screen, press second, and then press quit. So you're back on the home screen. We don't want to be entering stuff into the matrix once we put our coefficients in. The last step, second matrix again, the same command. Now you notice it says 3 by 4 because I have a matrix input in there. Go over to math and go down to, who remembers from the weekend?
Isn't it the RREF?
Very good. RREF. And there it is. Whoops, I passed it. Hit enter on that, and then go back to your matrix, and just press enter on matrix A. Hit enter, and you get your values. A burger costs $4, the fries cost $3, and the shake costs $2. If this is confusing to you, you need to do your homework and look at the matrix video. You have regular homework tonight. Make sure you keep it up with your work, please. And I'm pretty sure that your homework is due tomorrow, even though you don't have class, for timing for the week. I think I put it's due tomorrow for 3-6. So make sure to refer to Moodle for homework, please. That's fine. Thank you, Ina.